Assalamualaikum warahmatullahi wabarakatuh, and a very good day to the panels Puan Rahaiza binti Hamdan and Prof. Madya Dr. Muhammad Noor bin Abdullah. My name is Muhammad Zaim Marwan bin Mazlan, and my metric number is AA190070. So today I'm going to present about the final year project 1, which is the standalone small-scale solar system for emergency tent application. So for the project background, the idea is to introduce the standalone small-scale solar system for emergency application that produce maximum solar energy in and out tent for instant emergency purpose when there is no public grid connection in the area, so the standalone system are required. So for the solar tent, it will provide the electrical supply to various applications such as socket outlet, fan, lamp, and mini radio that work as basic needs when the emergency occur. So for the problem statement of the project, this first one is the risk of disaster in Malaysia has been increasing and disturbing in recent years. For example, like the floods, landslide, haze, and other man-made disaster, as well as few unusual earthquake and tsunami frequently temperature. So here attached is the data that we collected of the frequency of disaster happening by percentage. And next is the limitation of solar energy. Technology imposes is that energy can only be produced while sun is out. So it means that the supply can be interrupted at night and during the cloudy day. For project objective, we have three objectives here. So for the first one is to investigate and study the load analysis of solar power plant system by finding the total load and the power consumption of the tent to calculate the solar system sizing and find the suitable component used, such as the solar panel, type of charge controller, type of inverter, and type of battery. And next is to design and build prototype of standalone solar system for MGC 10. And for the third objective is to create the load calculator of solar power tent system via Excel spreadsheet. So this calculator will estimate you the suitable size of solar system used for your solar power tent by entering the size of a tent. Then it will show the suitable inverter sizing, battery sizing, and other component specification. And for the project scope, so for the first one is the type of hardware used in the project, 12-volt solar panel, PWM solar charge controller, solar battery bank, inverter, and various electrical appliances such as DC lamp, DC fan, and the socket outlet. So next is to design the prototype using the Tinkercad software and build the prototype of solar tent. And for the last one is develop the load calculator that can estimate the suitable size of solar tent, number of solar panel, and type of hardware used by using the Excel spreadsheet. Next is for the literature review. So in this part, there is more explanation about the study from the previous research and project in the development of the standalone small-scale system. So for the first one is the smart solar power tent. So the objective of the study is to create great energy and in the end to create such as huge tent that affordable price and enable it by utilized in rural regions with access to solar energy. Next is for integration of flexible photovoltaic modules on top of inflatable tents. So this solar system use flexible PV modules on the roof of an inflatable tent for refugees. So the whole design is lighter than any other refugee tent while having the integrated energy function. Next is the Softlight Solar Energy 10 Fly for Humanitarian Aid. So the Softlight is a device that certifies the demand for safe, portable, and ecological friendly off-grid electricity production. So it is used as a shelter for humanitarian aid. And next is for the Solar 10, a photovoltaic generator model for a flexible fabric with inbuilt cells. So the solar tent with inbuilt cells and the outer set about the system size is directly dependent on the consumer load profile and tent location. And the research also proved that using this system is better than the AC system in case of temporary short term. And last, for the research of design and performance of 20 watts portable solar generator. So the portable solar generator has been developed to generate electricity. It has the potential to replace the petrol generator widely used by peddlers at night markets. And the system also has the low maintenance, whereby the batteries need to be changed every 3 or 4 years, depending on the usage. So the main concept of the portable solar generator are to reduce installation costs and to introduce a compact design of an optimal energy sizing system. And now is for the methodology part. So the figure below shows the block diagram for the solar MGC 10 system. The first one is solar panel. So it generate the solar energy to electricity or heating before it connected to the charge controller that function as the regulator to regulate the voltage or current from the panels to the battery. So the battery function to store electrical energy in form of the DC and retrieve it for the later use. And charge controller also can be directly connected to DC load. So for the AC load, you need to change the direct current to AC current by using the inverter. So next is the flowchart of the project timeline. So it divided to 5 phases. For the first phase, we proposed the project title, which is the standalone small-scale solar system for MGC10 application. And that's by identifying the objectives and scope of the project and do the literature review. For the second phase, we calculate the load analysis in solar power tank system and also determining the suitable hardware used for the solar system sizing. And next, for third phase, we design the prototype and develop the hardware and prototype, also integrating the hardware with the solar system and testing the hardware. For the fourth phase, we design the load calculator and testing of the load calculator. And for the last phase, we record result analysis and do the documentation. And now for the preliminary result. So we show the total power consumption of solar power tank that we calculated, and the data was inserted into the table. So for the load is for LED bulb and fan, and we can see the total power consumed is 1300 watts. And I also decide to remove the 30 amp socket outlet because to reduce the cost on buying other component that suit my project, because a lot more of the power consumption use, and we need more high capacity of the battery and the solar inverter. And next is the battery sizing calculation for the system. So as you can see, we are using this formula and we got the 30 Ah. So we consider not going to complete discharge the battery and extract 10 Ah to the battery, and we decide to use 40 Ah. And next is for the solar panel power output calculation. So for the formula is we divide the age of the battery to the PSH, which means the peak sun hour in Malaysia. So the peak sun hour in Malaysia is range 4 to 6. So we assume to use 6 and times with voltage. So we got the solar panel power output of 60 watt and estimate it to 100 watt to charge the 30 Ah battery in 6 hours. And next is solar charge controller sizing calculation by dividing the solar panel power output and with the voltage, and we get the 10 amp rated current for the charge controller. For the inverter size of the system, it should be the 25% or 30% larger than the total watts. So the total load connected is 360 watt, means that inverter rated more than can be used is 480 watts. So we decide to use 500 watt inverter. And now the project redesign using the Tinkercad software. So this is a design for the tent and solar panels and also the load, which is the fan and the lamp. And the final design of the solar tent emergency test system. And next is for the expected result. So for the first one is developing the prototype of solar power tank, and the solar panel system should be able to generate enough electricity to electrical appliance, and storage system also allow to store the energy that be used when sunlight is not available, and ensuring the power is always available when needed, and also the effectiveness of using the load calculator. And next is for the future plan. So the first one is to ease the setup and use of the tank as well as its durability and resistant to extreme weather. And next is the potential impact of the solar emergency tank on disaster relief effort and the ability. And also the cost effectiveness and sustainability of the solar emergency tank compared to the traditional emergency shelter options. And also any future improvement and potential application for the solar load calculator. And that's all for my presentation today. and thank you for listening.